In this lesson, you are going to learn determinant 1, and under determinant 1, we are going to look at the determinant of order 2, and secondly, we're going to look at how to solve simultaneous equation using determinants. You should put it at the back of your mind that the determinant of order 2 is also known as the determinant of a 2 by 2 matrix. That is, a matrix that has 2 rows and 2 columns. In this lesson, we are going to write det A as the determinant of matrix A, although there are other ways we can represent determinants. Now, if you're asked to represent the determinant of A, we have det A equals that. So you simply write det A equals the absolute value of whatsoever you have inside the matrix. So what you do is to subtract the multiplication of the lower diagonal from the multiplication of the upper diagonal. So that is the upper diagonal and that is the lower diagonal. So you have the multiplication of the lower diagonal, you subtract it from the upper diagonal. If you are asked to find the determinant of A, where A is that, so if A is that, how do you find the determinant? So what you do is basically to just subtract the multiplication of the lower diagonal from the multiplication of the upper diagonal. So det A equals the absolute value. Remember, you have to represent, you have to include the absolute value. So from here now, we multiply the upper diagonal, we have 2 times minus 5, then we have minus 3 times 1. So we are subtracting the lower diagonal from the upper diagonal. So we have 2 times minus 5 minus 3 times 1. So after doing that, then you proceed by multiplying 2 times minus 5 to give us minus 10, minus 3 times 1 will give us 3. Minus 10 minus 3 will give us minus 13. That means the determinant of A equals minus 13. You can also find the unknowns in a simultaneous equation using the determinant of a matrix. You can find the unknown in a simultaneous equation using the determinant of a matrix. If you're asked to find x and y in this simultaneous equation, you can definitely do it. So we're asked to find the unknown x and y. So what we'll do is we'll find det A, det x, and det y. I'm going to explain what det A is, det x, and det y what they are as we proceed. So firstly, we are looking for det A. So to do that, we represent the matrix A. Before that, we need to represent the simultaneous equation in a matrix form. So basically, we extract the coefficients of the variables we have, x and y. So basically, look at the simultaneous equation. We just basically extracted the variables. We have 2 as the coefficient of x, then we have 3 as the coefficient of y, we have 1 as the coefficient of x, and we have minus 5 as the coefficient of y. Then we are dealing with 2 unknowns, x and y, so we have that equals to 12 and minus 7. So from here now we can extract the matrix A to be 2, 3, 1, minus 5, and from there we can find det A. Now we have done this in our previous example, but we are still going to do it now. To find det A, we basically need to we replace the parentheses with the absolute value. So we have that, and we basically subtract the lower diagonal from the upper diagonal. So we have 2 times minus 5 minus 3 times 1. 2 times minus 5 will give us minus 10, and 3 times 1 will give us 3. So we have minus 10 minus 3. Minus 10 minus 3 will give us minus 13. So det A will give us minus 13. So the next thing for us to do now is to find det x. So how do we find the matrix x? So we basically replace 2 and 1 that you're looking at there. We replace it with 12 and minus 7. So replacing it, we will get the matrix x. So the matrix x will be 12, 3, minus 7, minus 5. So we basically find the determinant of, we can now find the determinant of x. So find the determinant of x, we subtract the lower diagonal from the upper diagonal. So we have 12 times minus 5 minus 3 times minus 7. 12 times minus 5 will give us minus 60, then minus 3 times minus 7 will give us minus 21. minus 60 minus 21, minus times minus will give us plus. That's minus 60 plus 21 will give us minus 39. So that means that x equals minus 39. So lastly, before we find x and y, we find that y. So to represent y, we replace 3 and minus 5, replace it with 12 and minus 7. So we basically have the matrix y. So matrix y will give us 2, 1, 12, minus 7. So we now find the determinant of matrix y. So find the determinant of matrix y, we subtract the lower diagonal from the upper diagonal. So we have 2 times minus 7 minus 12 times 1. So subtracting the lower diagonal, we have 2 times minus 7 minus 12 times 1. 2 times minus 7 will give us minus 14, and that's minus 12 times 1 will give us 12. Minus 14 minus 12 basically will give us minus 26. So that y, determinant of y, is minus 26. So we have gotten that a, that x, and that y. So what we need to find now is x and y. So to find x, we'll basically use the formula that you are seeing right now. X equals that x divided by that a. That x divided by that a. So we'll substitute the value of that x and we'll substitute the value of that a. So from there we have minus 39 divided by minus 13. Minus will cancel minus, and 39 divided by 13 will give us 3. So the next thing is to find y. Finding y, we divide that y by that a. So we'll substitute the value of that y and that a. The value of that y is minus 26 and the value of that a is minus 13. So minus will cancel minus. 26 divided by 13 will give us 2. So we have looked for x and y. X is 3 and y is 2.